Alright, in this video we're going to talk about something called a piecewise function, and you can probably tell from looking at the picture on the right and also from the name of a piecewise function. It's basically a function that involves slicing a line into different pieces or different sections. So we want to do two things here. First we'll graph a piecewise function, that's number one, and then this one, number two, we'll take that graph and we'll write the function that produces that graph. So here's the main idea, or the main way to graph a piecewise function. We've already kind of done it. We know how to graph things in slope-intercept form. The only difference here is we have to graph them only in the positions or only in the points where x meets the conditions that we're given. So what does that mean? Well, notice here that we're supposed to graph the line negative x minus 3, and that's a line in slope-intercept form, but we're only supposed to graph that for x less than negative 4. So here's what I mean by that. If you were to graph negative x minus 3, here's the y-intercept of negative 3, and then we're supposed to go down 1 over 1, or again we can go up 1 over 1 and so on. So this is what the line would look like roughly. But notice that we're only supposed to do it for when x's are less than negative 4, and that's over here. So all of this part of the graph should not appear on our picture. So here's what I think is the easiest way to do this, and the steps are written here. Essentially, to graph each part of this, all we want to do is take 2 points, plug in 2 points, and the reason that we need to plug in 2 points is because you can get a line from any 2 points. If you have a point here and a point here, there's only one line that goes through those points. So let's simply get our 2 points and then we'll be able to have the graph. So the first piece right here, we're going to get 2 points, and we need both of these points to meet this condition. We need both of them to be true for, it needs to be true for x, that x is less than negative 4. So let's plug in negative 4 and let's plug in negative 5, since those are, well, now you might say, well, what about it says x is less than negative 4, why are we plugging in negative 4? And you'll see why in just a sec. So let's plug those points in. So we plug in negative 4 for x right here, we'd have negative 4, which is positive 4, minus 3 would be 1. So the point negative 4, 1 is going to be on our graph. And then we'll take this x value right here, negative 5, and we'll also plug it in for x right here. So we'd have negative x, that's negative 5, which is positive 5, and positive 5 minus 3, and that would be 2. So negative 5, 2 is on our graph right here. And then negative 4, 1, I'm going to put a circle right there. And notice I left the circle open. And the reason I left it open is because this is telling us x is less than negative 4. It doesn't actually reach that point right there. It gets right up close to it, so it hits right there, that line that I connected, but it never actually fills that point in because it's only less than negative 4. And then we just draw the rest of the graph going this way. And now we've taken care of that first piece right there. Alright, see if you can pause it and try and graph these other 2 pieces right here. Same procedure. So the second point, again, we still need 2 points, and they've given us both of these points here. They've told us x is negative 4. X is greater than negative 4, but it's less than 0. So all I'm doing here is plugging in negative 4 and 0. Those are our 2 boundary points. X is not going to be anything outside of that category. So let's plug in negative 4 here first. So negative 2 times negative 4 is positive 8, and 8 minus 3 would be 5. So negative 4, 5, that's going to put us right here. Now notice that I shaded that in this time. I filled it in, unlike that blue circle which we did not shade in, and the reason why is because of because of that right there. It says x is greater than or equal to, and so the equal to means that we shaded in. Okay, now we'll plug in 0 right here. So negative 2 times 0 is 0, minus 3 would be negative 3. So 0, negative 3 puts us right here, and there is our second piece of the graph. Just that line segment right there. All we're doing is graphing this line, negative 2x minus 3. It has a y-intercept of negative 3. But notice that we're not graphing anything over here or anything over here because the condition says x can only be between negative 4 and 0. And that's exactly how we signify that. Alright, if you haven't tried, try and see if you can once again pause and fill in that third piece right there. And then we'll do that together right now. So third piece right here, again, we need 2 points. Just separate this off right here. We need 2 points. One of the points should be, just like up here we pick negative 4 as one of our points. Here we pick negative 4 and 0. One of our 2 points should always be this number that they're giving us right here. So they're giving us x in comparison with 0. So I'm going to use one of my points as x is 0. And then our second point will be, we need numbers, this says greater than 0. So actually, let me get rid of this sign right here so it doesn't confuse you. That's greater than 0, not greater than equal to. So a number greater than 0, of course, would be 1. You could pick any number, but why not keep it simple? Pick 1. Okay, now we need to go here and plug in 0 first of all. So 2 times 0 is 0, plus 1 would be 1. So 0, 1. And then same thing, we'll go here and plug in this number 1. 2 times 1 is 2, and 2 plus 1 gives us 3. So we have the point 1 comma 3, and then 0, 1. I want you to ask yourself this question. Think about it for a sec. 0, 1, based on this right here, should that be shaded in like these two red points right here, or should it be unshaded in like that blue one which I just outlined in purple? And hopefully you came up with the answer. The answer is that it should be unshaded in. So 0, 1, I'm not going to shade that because that does not say x is greater than or equal to 0. It only is greater than. And then we connect the dots, and that is our piecewise function. That's what it looks like right there. Alright, so now on number 2, let's see if we can go the other direction right here. So now we want to take this graph and write a function like this g of x function. We'll call it f of x. It doesn't really matter which one we use, which letter I should say. So f of x equals, and we have this kind of curly brace thing that indicates it's piecewise. And before we get the lines, let's focus on the conditions here. That's probably easier. So this first condition, this line that I'm outlining in purple right here, it looks like that goes right up to where x is -2, because here's -2 right here, and then x is going to be less than or equal to -2 because it just keeps going to the left of -2. So all we're doing here is just filling in our conditions. Okay, the next one, the middle point, that's x is -2. Notice that x gets greater than -2. It doesn't actually equal -2 on this blue one that I'm tracing. And then it goes all the way to, it looks like x is 4 right there. So x is greater than -2, but it's less than or equal to +4. Why is it less than or equal to? Because this point was shaded in, even before I shaded in blue, it was shaded in red. Alright, this last part right here, it looks like x is going to be greater than 4, only greater than 4, and it just keeps going on forever to the right. So that arrow means it keeps going, so x is greater than 4. Alright, so we have our conditions. Now let's get our equations for the line. So we'll start with this purple one right here. So it looks like the slope is going down 2 over 2, or down 1 over 1, so that's a slope of -1, or -1x. Remember, we're using slope-intercept form, so I'm trying to write these in the form y equals mx plus b. We found out that m is -1 because it's going down 1 over 1. And then the y-intercept, well, you could keep following this out, but it's probably easier to do it like this. Let's say y equals -x. We're using this one up here. Y equals -x, and then we don't know what the b is. So here's what we can do, and we've done this before. When you don't know what the b is, you can take any point on this graph, and I'm going to take this point right where the purple dot is. That's at -2, 4. -2, 4 is on that graph, so I'm going to plug in 4 for y and -2 for x, and this is the easy way for us to find b. So -2 is +2, and if you solve this equation for b by subtracting 2 from both sides, you would get b is equal to +2. So that is the equation for this purple line right here. B, or -x plus 2, is equal to that line. Okay. See if you can pause the video and try and find the equation for those other two segments as well. Alright, so the blue line clearly has a negative slope as well, so that's the first thing, is let's find out what the slope is. And it looks like it's also -1. Like right here, for example, it's going down 1 over 1 right there, so it's still a slope of -1x. And then again, we need to have the plus b part. So let's pick a point on this graph, and how about this point right here that I just kind of highlighted extra thickly? That's the point 4 comma -3. So I'm going to plug in -3 for y and 4 for x. -4 plus b equals -3. Let's add 4 to both sides. And when we do that, we get b equals -3 plus 4 is 1. So b equals 1. There's our second of the 3 pieces. And then the final piece is this kind of this red or maroon color at the end. That clearly has a positive slope. So let's make sure that our answer reflects that. And the slope, once again, looks like it's a slope of 1. It's going up 2 over 2, or up 1 over 1. That's +1 then. And then we need to find our b value. So let's pick a point on this graph, and it looks like there's a point on the graph. That's the point 6 comma 2. So x equals 6, y equals 2, so I'm going to plug in 2 for y and 6 for x, and we're doing this so that we can find out what the y-intercept is. 2 minus 6 is equal to -4. So actually, instead of writing plus -4, we'll write it as -4, and this is the piecewise function that has this as its graph, using that reasoning laid out there.